Alright, good morning or evening or wherever you are. My name is Marvin and we'll be looking at the geometric interpretation behind tan x. The derivative of tan x, I mean. So, yeah, when you have anything that's trigonometric, it probably has a geometric interpretation that looks very good if you bother to look for it. So that's what we're going to do. So let y equals tan theta. So that would mean dy over d theta would equal, and it's cos square theta. I'm sure you have seen this before, and if you search it up, this is what you get. But why? Now we can use the quotient rule to find this. Now it's completely optional because there's a better way of doing that. And the better way of doing that is none other than graphing it out. So when you think trigonometry, you can always go back to the unit circle. The unit circle forms the fundamentals of what you need to understand with trigonometry, even in calculus. Now, okay, this isn't a perfect circle. Pretend it is. It's a unit circle, so it has a radius of 1. So this here has a radius of 1. And you might have seen this before. Oops. It's way too tiny. If I draw a triangle here, and this is a right angle triangle, this over here is, if I let this be theta, this will be tan theta. And you should see this before, and you'll know this is 1 over cos theta or sec theta, because tan theta is this divided by this, that's tan theta, that's correct. This divided by this should be cos theta. So if this is 1, this has to be 1 over cos theta, so that you equal to cos theta. So that's trigonometry stuff. If you don't understand that, you should probably revise your trigonometry. But we're not stopping there, because we're looking at the calculus point of view. And if we have a tiny nudge in this line, and we just move it just a little bit, we can get a change in whatever this line is, because calculus is about the change. But of course, I can't do a tiny nudge because my art skills aren't that good and you won't be able to see anything. So for the sake of this video, I'm going to make it really obvious. So this over here, this whole stretch, that's d theta. This over here is your change in y. So this is your dy, a very small change. Remember, it's a tiny nudge, and you gotta pretend this is so tiny, like small, way smaller than a dot. You can't even see it. That's how tiny it should be. But of course, you wouldn't be able to see anything. Hence why we need to draw this at an enlarged version. In fact, this is still not big enough. I need more space, so I'm going to draw a huge triangle here. I'll pretend it's perfect. Dy, just move everything we have over, d theta, and this is sec theta, 1 over cos, 1 over cos theta. It's very good. And is that it? Of course not. So when you think about trigonometry, you always want to think about what are the other angles. So over here we can see we got theta and 90. Perfect. We can find this side just by taking 180 minus these two sides. This will give us 90 minus theta. Therefore, this has to be, if I take 180 minus this, that will give me this side. This has to be 90 plus theta. Alright? And I think you know what I'm alluding to right now, just by doing this. I want to use the sine rule by finding the relationships between the sides. So if I can find a relationship between this tiny angle over here and this tiny change in the y value, which is the outcome of tan theta, or the change in tan theta, I've solved the problem. That's exactly what I want. And therefore, in order to make that true, I need to make it proportional to something else. That is none other than the side we already know, which is sec theta. That's the only value that we understand from this graph, and also 90 plus theta. But of course, the sine rule only works if they're opposite each other, and we can find this value if we just take 180 minus all of this. And if my maths doesn't fail me, this should be what we should get. Yay! We can now apply the formula. What's a good color? Let's take orange. Now, that's very simple. Sine d theta over dy, so this side and this side will equal, is proportional to the ratio between these two. And we got to be very careful here. The signs should all be on one side according to the sine rule. 90 minus theta minus d theta all over sec theta. Alright, now what? Okay, so you're gonna see a very special thing in mathematics, and that's sine d theta will always equal d theta. And I'm not making this up. If you graph sine x and y equals sine x and y equals x on the same graph, when you zoom in into the origin, you'll see that they are indeed the same line. You can try this out yourself with like Desmos or a graphics calculator. But this value here has to be a very tiny value. And for our case, that's very convenient because it is. It's calculus. So sine d theta does equal d theta. This is constantly used in physics and many other areas where you need that convenience. So that's perfect. And same rule applies here. This is a very tiny value. Okay, this is the same as sine 90 minus theta. You might say that's cheating. You can't just remove the d theta. You might as well say this is 0 over 0. Well, for our case, this is inside a sine graph. If you put this into your calculator, if you take sine 90 minus theta minus 0.000000001, the calculator sees it as sine 90 minus theta. So for our case, we can just take a look at it as if it's that. And this is 1 over cos theta. I'm going to open this up for a convenient reason later, and that is because I want to put this up here. 1 divided by 1 over cos theta is cos theta. It's the same thing we got here. Alright? And you might notice sine 90 minus theta is the same as cos theta. You can use the trigonometric identity to find out that that is indeed true. You can graph this. But for our case, we're not going to do that. We know it's true. Cos theta times 1 divided by 1 divided by cos theta is simply cos theta, or in other words, cos square theta. You might say, wait a second, that is not what we have here. That's 1 over cos square theta. We did something wrong. No, we haven't. Over here, you might notice that it's d theta over dy. So everything's in respect to y. No, everything's in respect to y. That's not what we're looking for. The relationship is y equals tan theta, not theta equals tan y. So because this is still algebra, it's very convenient. We can just, take the toe over to its head, do the same for the other side. QED. Smiley face. There we go. Alright, so let's just review what we did here. We started out with this, that's what we want to prove. We started with the unit circle. Always start with the unit circle. That gives you the most ideas. This fundamental in trigonometry. Alright, and from this, we can use this to use sine rule. And that gives us relationships between sides. And the most important relationship here is between d theta and dy. That's exactly what we're looking for. We're trying to find a proportionality. We're trying to find how the very tiny changes would affect each other. Okay? And using the convenient values that we're given over, that's provided to us by the unit circle, we can go ahead and fill in the rest of the angles and get what we want. I know this is a little bit cheating here where we remove d theta, but that's the only way forward. And it also seems a little bit cheating that we did this, that's very theoretical, but that's pretty much well accepted in maths and physics. And, I know it's weird to say, well, if this is just 0, then this is just a straight line. That would be 90 minus theta, and that would be 90 plus theta. That doesn't make sense, I know it's strange, but it's calculus. It is strange. This is the same as cos theta. Bring this up, cos theta, cos square. Take it upside down. You get what you want. And that is the geometric interpretation. I know there are some things you just gotta take it for granted like this, and that's just a part of the process when you think about geometry with calculus. It's a paradoxical concept, and that's why you get very paradoxical ideas. But there are ways to think around them. You may or may not like them, but this is just one rendition of that. Hope you enjoy.